My favorite section and lesson in all of math is 7.2. It's called Verifying Identities. And what we're going to do is show how one side is equal to the other side. So let me show you. I have a few examples for us. The directions for these examples are going to be to verify the following. So we'll take a look at an example like this first. Let's say 1 minus secant of x times the cosecant of x times the tangent of x is equal to negative tangent squared of x. And the way that all these problems work is we always pick the harder side, or let's say choose the harder side. And you're not allowed to touch the other. Don't touch the other side. Okay, so for this problem, this side is clearly the more complicated side, or the harder side. Second step is we use properties to simplify. Now we've talked about a few different properties. One thing that we talked about is the reciprocal properties. We talked about the quotient properties, the Pythagorean identities. We've seen even and odd functions. Now, other tools that we could use to simplify are factor, and get a common denominator. Excuse me. Okay. Generally, what we do is we convert to sines and cosines, and then we either factor or get a common denominator to finish. So let me show you with our examples. First thing I would do to get started is on the left side, I would say 1 minus 1 over cosine. Let's convert these to sines and cosines. Cosecant is 1 over sine, and tangent is sine over cosine. So taking a look at this, these signs cancel, and we get 1 minus 1 over cosine squared of x. Now for these problems, usually there's multiple ways to finish them. One thing we could do from here is we could say that this is 1 minus the secant squared of x. And that kind of looks like a Pythagorean identity. If you take a look at what we have, secant squared and tangent squared, there's an identity that says tangent squared plus 1 is equal to secant squared. So what would 1 minus the secant squared be? Well, if we rearrange this, we'd get 1 minus the secant squared of x is equal to negative tangent squared of x. And all you have to do is just show that work. And that would be it. We just showed how we turn the left side into the right side. That would be one way to finish it. A second way to finish this problem is to keep things in terms of sines and cosines. So the second technique would be to go with 1 minus 1 over cosine squared of x, and get a common denominator. So we can multiply the 1 by cosine squared over cosine squared. And you'd get cosine squared of x minus 1 all over cosine squared of x. Well, if you think about what we have to get tangent, right? Tangent squared. Somehow we have to get a sine squared on top. And if sine squared plus cosine squared is 1, if we subtract 1 on both sides and bring the sine over, that would mean that cosine squared of x minus 1 is equal to negative sine squared of x. So this turns into negative sine squared of x over cosine squared of x, which is negative tangent squared of x. I think for most people, from my experience, most people prefer to just convert to sines and cosines and then see through to the end of the problem doing that. I don't expect you to get this from the first problems. We have a few more. How about something like this? Let's go secant of x minus cosine of x over cosine of x is equal to tangent squared of x. All right, well, let's pick the more complicated side. And we could do this a few different ways. I'll show you 2 ways to do this. One thing we could do is we could actually break up the fractions. We could write this as secant of x over cosine of x minus cosine of x over cosine of x. We're dividing by a monomial, so we're allowed to do that. Secant is 1 over cosine. We're dividing by cosine and subtracting 1. So when you divide by cosine, that's the same thing as multiplying by the reciprocal. 1 over cosine squared is secant squared of x minus 1. And remember from our Pythagorean identity, we know that tan squared plus 1 is equal to secant squared. So what's secant squared minus 1? Just tangent squared. And we just showed how the left side turns into the right. Now that's a little bit more advanced. Let me show you the way I think most of you would want to do this problem. Let's convert secant to 1 over cosine minus cosine, all divided by cosine of x. Now, we convert it to sines and cosines. Let's get a common denominator on top. I'll have to multiply this cosine by cosine over cosine. And we get 1 minus cosine squared of x over cosine of x. That's the numerator, divided by cosine. Well, I'm seeing 1 minus cosine squared, and I know I have to get tangent, which is sine over cosine. So if sine squared plus cosine squared is 1, 1 minus cosine squared is sine squared. So I get sine squared of x over cosine of x times 1 over cosine of x gives us sine squared of x over cosine squared of x, which is just tangent squared of x. Moving to our third example, what if we had negative 2 cotangent squared of x is equal to 1 over 1 minus the secant of x plus 1 over 1 plus the secant of x. Looks like the right side's more complicated this time. So let's get a common denominator. The least common denominator would be 1 plus secant times 1 minus secant. So I'm going to multiply by what we're missing. I'm going to multiply this fraction by 1 plus secant over 1 plus secant I'm going to multiply this fraction by 1 minus secant over 1 minus secant. And let's see what we get. Because they would have the same denominator, I'm going to have 1 plus secant of x times 1 plus 1 minus secant of x times 1 all over the same denominator, which was 1 minus secant of x times 1 plus secant of x. In the numerator, these cancel. 1 plus 1 is 2. And in our denominator, 1 times 1 is 1. I'm just going to FOIL that out or distribute it. Secants cancel. And we see the same Pythagorean theorem that we had before. 1 minus secant squared of x. Well, if we know that tangent squared plus 1 is secant squared, 1 minus secant is equal to negative tangent squared. So we wind up getting 2 over negative tangent squared of x, which we could then write negative 2 cotangent squared of x. To bring tangent to the top, it turns into cotangent. That was the left side. Move on to problem number 4. What if we had sine squared of theta, cosine squared of theta, minus cosine squared of theta, and this is equal to negative cosine to the 4th of theta? Well, this looks like the harder side. We do have all sines and cosines, so we could do this problem a couple different ways. One thing that we could do is factor. I see that we have a cosine squared in each term, so if I factor out a cosine squared of theta, I get sine squared of theta minus 1. Remember, we're just dividing both of these terms by cosine squared. That's what factor means. Factor is just another word for divide. And that's what we get. And then I see a Pythagorean identity here. Sine squared plus cosine squared is 1. So what's sine squared minus 1? Negative cosine squared. So this just turns into cosine squared of theta times negative cosine squared of theta is negative cosine to the 4th of theta. That's what that turns into. Another way to do this, and one way is not better than the other, just kind of looking at this, I see the left side has a sine squared in it, and the right side just has cosines in it, cosine to the 4th. So what I'm going to do first is I'm just going to get rid of that sine squared. If my answer has all cosines, I'm going to get the left to have all cosines. So if sine squared plus cosine squared is 1, that means that sine squared is equal to 1 minus cosine squared. So instead of having sine squared theta, cosine squared theta minus cosine squared theta, I'm going to replace the sine squared with 1 minus cosine squared of theta. And we could distribute here. This would turn into cosine squared of theta minus cosine to the 4th of theta minus cosine squared theta. These would cancel, giving us just negative cosine to the 4th of theta, which is what we wanted. There's plenty of supplemental material, so you can go to the link and hash out these problems. But the more you practice, the better you'll get. Let's finish with one more example. Let's take 4 times secant squared theta plus 4 secant theta plus 1 over 2 secant theta plus 1. Somehow this has to turn into 2 over cosine of theta plus 1. All right, so I'll show you two techniques. Now on the left, I see everything's secant, and one thing that's interesting to me is the top actually looks like a trinomial. So let's try to factor that top. What are two numbers that multiply to be 4 times 1 and add up to be 4? 2 and 2, right? So the top, let's see if we could factor by grouping. 4 secant squared theta, but instead of 4 secant theta, I'm going to write our numbers 2 secant plus 2 secant, and then plus 1, all divided by 2 secant of theta plus 1. I'm going to cut this down the middle. I could take out a 2 secant of theta, that's our GCF, and this would be 2 secant theta plus 1, plus we could just take out a 1 here, we'd get 2 secant theta plus 1. We could see that we do have the same GCF between both terms. We could take out that GCF, 2 secant of theta plus 1 times 2 secant of theta plus 1 all over the denominator. And we actually have the same factor on top and bottom, giving us just 2 secant of theta plus 1. And remember what secant was. Secant was 1 over cosine. Giving us just 2 over cosine of theta plus 1, which is what we were supposed to get. That was pretty fun or interesting. But so now you've seen all the different ways to solve these problems. I've showed you all different variations. You just have to practice some more. Let's try doing this with sines and cosines. So instead of secant squared, I'm going to write cosine squared. All right, so we converted to all sines and cosines. Now on top, my least common denominator is going to be cosine squared. So what I'm going to do is multiply by whatever factor we're missing. I need to make this cosine theta over cosine theta to get cosine squared in the bottom. I have to multiply the 1 by cosine squared of theta over cosine squared of theta. So the top turns into 4 plus 4 cosine theta plus cosine squared of theta all over the common denominator of cosine squared of theta. That's my numerator. Now the denominator, the LCD for the denominator, is going to just be cosine of theta. So I'll multiply the 1 by cosine over cosine, which gives us 2 plus cosine of theta all over cosine of theta. Okay, now let's keep change flip and let's see what we're dealing with here. I'm going to rewrite this as cosine squared of theta plus 4 cosine theta plus 4. And over cosine squared of theta. I'm going to be dividing by 2 plus cosine over cosine. So that just turns into multiplying by the reciprocal. One of these factors cancels with one of these factors. And we could actually factor this trinomial. That would factor to be cosine of theta plus 2 times cosine of theta plus 2. Divided by the denominator, which is cosine times cosine of theta plus 2. Now these are the same factors. We're dividing and multiplying by the same factors. And we could write cosine of theta over cosine of theta plus 2 over cosine of theta, which gives us the same exact answer. 2 over cosine of theta plus 1 is exactly what we got on the other side. Now, if you want, there's supplemental material available. Just click on the link. But also, there's plenty of practice problems online and in our textbook. There's additional problems you could look on or try in the book on page 662. The odd problems are in the back. I hope you enjoyed that lesson. I look at this as having like a necklace, a really thin necklace that's tangled up. And you pick the one side that's all in a knot, and once you untangle that knot, you get the other side, or you get an untangled necklace. Thank you very much. Stay tuned for our next lesson.